Let's evaluate the integral of x e to the power x by 1 plus x whole thing square as x changes from 0 to 1. So this is a definite integral and we want to evaluate this integral. So we want to evaluate the integral of 0 to 1 x times e to the power x by 1 plus x whole thing square dx. Observe that if I write x as x plus 1 minus 1, then I can write this as sum of two integral or difference of two integral. Let's do it. So we write as x plus 1 and then minus 1. Rest of the expression we copy as it is. E to the power x copied, x plus 1 whole thing square copied, dx copied. Now we can write it as difference of two integral and let's do it. So this integral equal to integral 0 to 1 x plus 1 by x plus 1 whole thing square times e to the power x minus integral 0 to 1 by x plus 1 whole thing square times e to the power x dx. Okay, we can cancel x plus 1 out and write it as integral 0 to 1 e to the power x by x plus 1 dx minus integral 0 to 1 e to the power x by x plus 1 whole thing square dx. You see, we won't be able to evaluate the definite integral of e to the power x by x plus 1, or rather we won't be able to evaluate the indefinite integral of e to the power x by x plus 1. Neither is it that it is possible to evaluate the indefinite integral of e to the power x by x plus 1 whole thing square. We don't have any closed form for that. However, we can evaluate the difference. Let's do it and let's see how. So we consider the indefinite integral. For the time being, of course, we'll just put the limit. The indefinite integral e to the power x divided by x plus 1 dx minus e to the power x divided by x plus 1 whole thing square dx, which can be written as integral of this one can be written as 1 by x plus 1 times e to the power x, and so the integral is integral of product of two functions. The second one we copy as it is. So we want to apply product rule. Once again, we want to apply product rule. Whenever we say product rule, we need to make sure which one should be the first function so that will ease our work. We have got something called I-late rule. I-L-A-T-E. I stand for inverse function or inverse trigonometric function. L stand for logarithmic function. A stand for algebraic function. T stand for trigonometric function. And E expand for exponential function. Whichever occurs first, we will do it. Does inverse trigonometric function occur here? No, it doesn't occur. So we will not regard inverse trigonometric function to be the first function. Does logarithmic function occur here? No, so we will not regard logarithmic function to be the first function. Does algebraic function occur? Yes. 1 by x plus 1, we can regard it as algebraic function. Of course, everything could be algebraic, but we will regard polynomial by polynomial to be algebraic. So this one occurs as first function. So we will regard it as first function and apply UB rule or product rule. What exactly is product rule? Let's write it down. Product rule says integral of u times v dx. There are two functions u and v, and so the integral of product equal to first function, which is just u, times integral of v dx minus integral of derivative of first function. So u dash, we need to just differentiate the first function, and then integral of v dx, integration of second function, and this product has to be integrated once again. That's the product rule. We got u equal to 1 by x plus 1. Let's call this integral to be I1 equal to this, and let's call this integral to be equal to I. So I should write let this equal to I, and let this one to be equal to I1. Let I1 equal to this. Currently we are evaluating I1, and we will just put the limit to get the value of I. First function is 1 by x plus 1. Second function is e to the power x. Fine. First function is 1 by x plus 1. So integral of 1 by x plus 1. Second function is e to the power x dx equal to, by the UV rule or product rule, first function u 1 by x plus 1, and then integral of second function. So integral of e to the power x dx minus integration of derivative of first function or d dx of x plus 1 to the power minus 1, and then integral of v or integral of second function. So integral of e to the power x dx, and this product has to be integrated once again. Quite a lot of things, right? But we have to do it. Let's do it. So first function is 1 by x plus 1. Integral of e to the power x is just e to the power x, quite easy, right? Minus integral of derivative of x plus 1 to the power minus 1, that's minus 1 x plus 1 to the power minus 2. And then integral of e to the power x is just e to the power x, and this product has to be integrated once again. Okay, something strange happens. So this is equal to 1 by x plus 1 e to the power x, negative of negative is positive, and then e to the power x by x plus 1 whole thing square dx. Let's look at the I1. We got I1 equal to this expression. Once again, we got I1 is exactly equal to integral of e to the power x by x plus 1 minus integral of e to the power x by x plus 1 whole thing square. So I1 equal to integral of e to the power x by x plus 1 e to the power x by x plus 1 dx minus integral of e to the power x by x plus 1 whole thing square dx. As we said, something strange happens, and you see that e to the power x by x plus 1 dx, we just evaluated it, and that turns out to be e to the power x divided by x plus 1 plus integral of e to the power x by x plus 1 whole thing square dx. That's just the integration of e to the power x by x plus 1. That turns out to be e to the power x by x plus 1 plus integration of e to the power x by x plus 1 whole thing square. We wrote it exactly. This integration we just computed it. Once again, this integration has been computed just now. The other one we copy as it is. As we said, something strange happens. That makes our work easier. See that this one is positive and this one is negative, and we can cancel this out. Okay, when we cancel it out, it turns out that I1 is simply equal to e to the power x by x plus 1. Of course, this is an indefinite integral, so I should write some constant of integration. What is I? I is just the definite integral as x changes from 0 to 1. I is just definite integral as x changes from 0 to 1. So I equal to 0 to 1 x e to the power x divided by x plus 1 whole thing square dx. That's equal to e to the power x by x plus 1 is x change from 0 to 1. We don't have to write the constant because constant will get cancelled. So that's equal to e to the power 1 by 1 plus 1 minus e to the power 0 by 0 plus 1. That's equal to e by 2 minus 1.